Hello all and welcome to the Math 8 video for combining like terms. In this section we'll be talking about expressions and then looking at some complex expressions and simplifying them by doing this process we call combining like terms. Okay, so combining like terms. So the first thing we need to do before we get into combining like terms is talk about the parts of an expression. Okay, so at this point, everybody here should know what an expression is, just something in math that's basically like a math sentence here, okay? So what this sentence tells us is we've got 14 times x plus 9 minus 2 times x plus 8 minus 5 times x plus 1, okay? Now, in this case, we don't know what x is, okay? So x in this case is the variable, okay? So x is the variable. Now, at this point, we're not worried about finding what x is. X can be any number in this case, okay? But I do want to point out x is the variable for this expression, okay? So we see x represented here actually 3 different times, with the 14x, with the minusing of 2x, and with the minusing of 5x, okay? So with that being said, one of the first things, and you'll see me do this over and over and over again with a lot of these examples, is I want to rewrite my expression as a sum. Okay, so if you've talked about expressions before, you should know the word sum means addition. So in all these places where we have subtraction, I want to rewrite this expression to where the subtraction becomes addition. And how I'm going to do that is in every place where there is subtraction, I'm going to write a plus sign, but then I'm going to let the term after the minus sign take the negative with it. So what that means is instead of minus 5x, this becomes plus a negative 5x. Okay, so once again, this should be something most of you should be familiar with, writing addition as subtraction. If you haven't been up to this point, then you definitely will after this, because like I said, every single example I go through, I like to write my expressions as sums so I can clearly find the parts. Okay, so now it's finally time to talk about what parts I'm even mentioning here. Okay, so the parts of an expression that we have, we can break it up into two different sections here. We've got the variable terms and we've got the constant terms. Okay, so if you're looking at your notes there, it says variable terms. These are the parts, these are the terms that have a variable. Okay, hence why they're called variable terms. So if we look, the variable is x. So we need to look at each one of these terms, meaning all the things separated by addition. We need to look at all of these terms and figure out which ones have variables. Okay, so going through it very quickly here, we've got 14x. So right off the bat, the first term is what we call a variable term. Okay, because it's a term with a variable. The 9 is not a variable term. Since the 9 has no variable, okay, we're going to talk about what that is here in just a second, but the main thing here, it's not a variable term because there's no variable. We go to the negative 2x. Well, negative 2, well, there's that variable x, so it is also a variable term. Okay, and the last one here, which we go to 8, no variable, negative 5x has a variable. So these are what we're calling the variable terms, okay? Now this is different from just the variable. If the question was asking, okay, what's the variable of this expression, then you would say x, okay? What are the variable terms? It's all the terms that we have in the expression that have an x in it, okay? Well, if the terms don't have a variable, then that's what we call a constant term, okay? So we go through the 14x, it was a variable term, but remember just a second ago I was talking about this 9. There is no x with this 9, okay? So what that means is that 9 is going to stay a 9. It's not going to change, okay? If x changes, then the 14x will change because it depends on what you plug in for x. If you plug in 2, that'll be 28. If you plug in 1, it'll be 14, okay? But if you plug in an x with the 9, well, there's no x with the 9, so it's just going to stay a 9. So that's why we call it a constant term. So the constant terms, once again, are the numbers without a variable, or term without a variable. So we've got 9, 8, and 1. And at this point, if we have the variable terms listed out and the constant terms listed out, that should be all the terms of the expression. So if we look here, 1 term, 2 term, 1 term, 2 term, 3 term, 4 term, 5 term, 6 term. So we have 6 terms here. So down here we should have a total of 6 terms. So we have 1, 2, 3 variable terms and 1, 2, 3 constant terms. That makes 6 total terms. That means we got all the terms in our expression. Okay. Now this is a pretty convoluted, complex example that we're going to look at here in just a bit when we actually combine like terms, meaning there's a lot of operations going on here. I think there's a total of 8, so times, so 1, 2, 3, 4, 5, 6, 7, 8 different operations here going on, so we need to know how to deal with that to combine all these terms. But the last thing we're going to talk about in terms of parts of an expression, and this is probably the most important one, is this idea of a coefficient. Okay, so notice it's over here underneath the variable terms because it actually has it's directly tied in with the variable terms. So the coefficients, these are the numbers that are in front of our variables. So when we look in our original expression, every place we see a variable, we're looking at the number in front of it. So if we have the variable terms listed out here, it actually makes it very easy. 14x, well, what number is in front of this x? Well, that means the coefficient for that term is 14. Negative 2x, well, what's the coefficient in front of that term? Negative 2. Negative 5x, what's the coefficient in front of that x? Negative 5. Okay. And as far as these first types of questions and as far as what we're concerned with right now, that's all we're worried about right now is identifying the terms. So if you can identify the variable terms, you can identify the coefficients. And then whatever terms are left over after you deal with the variable terms, those are what we call the constant terms. Okay. So let's go ahead and jump into some examples. And this actually is a lot easier than it probably looks with that example. Because when we go to the first example, we have 11a plus 4a. Once again, just 2 terms here. And so the whole goal here is we want to look and say, well, what are the variable terms? What are the constant terms? And then after we know those two, then we can go down here and based off the variable terms, figure out what the coefficients are. Okay. So in this case, the variable terms, well, first off, we see that the variable is a. Okay, so the variable is a. So how many terms do we have with the letter A? Well, we have 11a with the letter A. We have 11a and 4a. So those are actually the variable terms. So 4a, I'm kind of writing them backwards here. So 4a and 11a. Once again, we're just listing them, so it doesn't matter what order we put them in here. So 11a and 4a. The constant terms then are what's left over. Well, do we have any more terms after we take out those 2 variable terms? No. So actually, constant terms, we can just write none or NA or just leave it blank. Okay. If there's no numbers after you get rid of the variable terms, then that means there's no constant terms. So the last thing here, very easy. Well, what are the coefficients? Well, we look at the variable. What's the number in front of this A? 4. What's the number in front of this A? 11. And that's pretty much it. That's all we're doing here is we're looking, determining which are the variable terms, which are the constant terms, and the coefficients. Now, number 2, we have it a little bit more difficult. So in this case, I am going to start abbreviating just to save some time here. So I'm going to put VT for variable terms, CT for constant terms, and just C for coefficient, just so we can save some time. So it's understood that variable terms, that's VT, constant terms, CT, and then coefficients is just C. So like I said, I'm just doing that to save some time here as we go through. We got a few examples to go through here. But once again, every single one of these is going to work the same. Okay. My first bit of business here, though, okay, with this example, and let me redo this so I can have a little bit more space. Because what I want to do is, notice here, we've got 3 times x plus 6 plus 7 times x minus 4. Now, some of you will get better with this as time goes on, and you don't necessarily have to rewrite this, but it's just in my preference that I like to rewrite my expressions where it is a sum, meaning I'm going to change the subtraction to addition. So now I can clearly see what my terms are, okay? So when I go here, once again, variable terms. Well, what are my variable terms? Well, first off, my variable is x, so it's going to be the terms that have x's in them. So 3x and 7x, okay? So those are the variable terms. Next, what's left over? Those are the constant terms. Okay, well, what are the constant terms here? Well, whatever's left over. So 6, that doesn't have a variable, so 6 is a constant term. And -4 is a constant term. Okay, and I put parentheses there. Technically, you don't need the parentheses. I just have a bad habit of, when I have negative numbers, putting parentheses there. But the terms are actually 6 and -4. Okay, and then lastly, since we know the variable terms, what are the coefficients? Well, that's pretty easy. What number's in front of this x? 3. What number's in front of this x? 7. Okay. Now, if you're confused as to why we want to do this, that's going to come in the second type of question, second part of the question, or second part of the lesson here, where we actually go through and combine the like terms. And if you know the coefficients, you know the variable terms, you know the constant terms, it makes combining these and simplifying these expressions so much easier. Okay, but let's go on to example 3. Same kind of thing here. We've got -12m minus 3 plus 4m plus 16. So as always, I like to rewrite my expressions. So -12m plus -3 plus 4m plus 16. So once again, I like to write my expressions as sums just so I can clearly see my terms and see what I'm going to be dealing with here in terms of what my terms, my variable terms, constant terms, and coefficients are. So same as always. And you can see we're going to go a little bit faster as we go here because once again, it kind of gets a little easier. Even though the questions get longer and longer here, as you see, the process is still the same, and it actually gets easier the more you do it. So in this case, variable terms, well, that's going to be -12m and 4m. I guess I should have said the variable here is m. Okay, so the variable did change here, so it is m. So in this case, constant terms. Well, what are the constant terms? Well, once again, whatever's left over. We've got -12m and 4m. Well, what are the other terms? -3 and 16. Okay. And lastly, the coefficients to me are the easiest because if you get the variable terms correct here, the coefficients are just the numbers in front of the variable. So in this case, -12 and 4. Okay. And like I said, that's pretty much all there is to it with these first examples, is identifying the different parts of an expression, so all the different terms. So number 4, same kind of thing, 6k minus 4 plus k minus 2. But in this case, if you want to maybe put a little star by your answer or your by this example, because there is something special that happens here, and it's something that you need to really remember how to do. But let's go on like we normally do. So in this case, we got 6k. So let's rewrite this. 6k, I'm going to put plus -4 plus k plus -2. Once again, same exact thing I've been doing in every example. Every place that I see subtraction, I like to write it as addition. So -4 becomes plus -4. -2 becomes plus -2. And that way I can clearly see my terms, especially my, in this case, constant terms. But let's go through and see what these variable terms are. So first off, variable terms. Once again, we need to identify the variable. The variable's k. Well, right off the bat, we see this 6k, so that's a variable term. But then we have this weird one where it's just the letter k. Okay, so we have the letter k, so that's actually a variable term. But here's where we have something special happen. If we just have a variable, so like in this case, just the letter k, and we'll see this in a few more examples here as we go on. But if we just have a k, technically the number in front of that is 1. So we have 1k. So if you like to, when you originally write the expression out, go ahead and put a 1 in front of your variable, okay? And once again, you can only do this if there's no number in front of your variable, okay? It's kind of understood that it's 1, but we do need to reference that because it's going to become important here in just a second when we talk about coefficients. But in this case, we have 6k, 1k. Well, those are the only two terms with k's. So what's left over? Well, those are our constant terms of -4 and -2. And lastly, just like always, once we know the variable terms, this part's the easiest. We have 6, but this is the part where a lot of people do get mixed up. A lot of people, once again, they don't see a number in front of the k, they just see k, and they forget that there's technically a coefficient in front of that k. So that's why I say it's strongly important, especially if you have trouble remembering this, write the 1 in front of your k, because one of your coefficients has to be a 1, okay? One of the numbers. So the number in front of that second k, okay, so just plus k here, that's technically a 1, okay? So that actually tells us that our coefficients are 6 and actually 1. All right, going on. So halfway mark here for the first set of examples. Once again, we want to look at the terms, but we see we have subtraction. And like I said, you don't have to do this. This is just something I prefer to do because it helps me see clearly what my terms are. So I'm going to rewrite my expressions with addition. So where it's 3 plus 13, that stays the same. And then instead of minus 5p, I'm going to write plus negative 5p. Instead of minus 2p, I'm going to write plus negative 2p. And once again, that's the only reason I want to do that is so I can clearly see what my terms are. So when I look at variable terms, well, first off, my variable's p. So my variable terms are negative 5p and negative 2p. Once again, the terms with the variable. Speed it up a little bit here. Constant terms are what's left over, so that's the 3 and 13. And the last step in every single one of these types of problems is, what are the coefficients? Well, whatever's in front of the variables here, so negative 5 and negative 2. Okay? And you can see how it gets pretty repetitive here, okay? Same thing pretty much every single time. And like I said, I do strongly recommend, if you don't see where I'm getting these numbers, I do strongly recommend writing your expressions as sums. Which, let me fix that plus sign there. That's a pretty bad one. There we go. Okay. So number 6, this one's actually a doozy, but because we have all this subtraction and negatives here, all these subtractions, and then we have a negative up here. But we do have that special thing happen here because, as you see, our second term here is actually going to be technically negative r, okay? But we'll see that clearly when we rewrite this. So I'm going to rewrite this as negative 10r plus negative r. Notice I'm kind of leaving a little space here because you'll see why here in just a second. Plus negative 6r plus 11. Now, once again, this is a special case because technically there is a number in front of that second r here. So it's just negative r, but we do need to understand that the number in front of that is 1. So technically you have negative 1r. And then, just like always, the last examples that we've done, we just go through. Variables are, so our terms negative, or our variable terms are negative 10r, negative 1r, and negative 6r. Okay? So once again, just all the terms with r in it. Be careful with this 1r here, so this r, because once again, technically, if you need to, go ahead and write that 1 in there so you understand there has to be a number in front of that, because like I said, it's important when we get to the coefficients. Constant terms, well, there's actually only one constant term this time because every single term has an r except for 11. Okay, so 11 is the only constant term. So then that leads us to the last part, which is which are the coefficients. So we have negative 10, negative 1. Once again, that's why this is important, because we need to know it's a negative 1, not a negative nothing or a negative 0. A lot of people want to think that there's a 0 in front of it, but that's not really true. Once again, we have 1r here. So we're subtracting 1r. That means our term is actually negative 1r. So that means our coefficient is negative 1. And then lastly, the last coefficient is negative 6. Alrighty, continuing on. Number 7, we actually go back to something maybe a little bit easier, I think, except in this case we only have one variable term because our variable's in here, but I still like to rewrite my expression. So I'm going to do 19 plus negative 5n plus negative 8 plus 14. Okay? And once again, same steps every single time. Variable terms, we're looking for the terms with variables. Well, 19 doesn't have a variable. Negative 8 doesn't have a variable. 14 doesn't have a variable, but negative 5n does. So the only variable term in this case is negative 5n. Okay, pretty straightforward. So what's left? Well, those are all the constant terms. Once again, the terms without variables. So that is 19, negative 8, and 14. Okay, once again, we're just listing them all out here. They don't have to be in any specific order, okay, because you'll see why, especially when we get to the next set of questions. But in this case, we just list them out, 19, negative 8, 14. And lastly, the coefficients are pretty easy here because since there's only one variable term, there's only one coefficient, negative 5. Okay. Now, number 8, same kind of deal here. We've got some subtraction. So, like I said, just a preference thing here. I'm going to rewrite my expression to include only addition. So now when I want to go look at my variable terms, well, first off, my variable is y. So negative 5 doesn't have a y, 18 doesn't have a y, but 13y does, and negative 2y does. Okay, so those are my two variable terms. My constant terms, in this case, are going to be what's left over, so the negative 5 and the 18. And once again, lastly with this example, the coefficients are going to be 13 and negative 2 because those are the numbers in front of the variables in the variable terms. Now the last two examples here, once again, kind of throw another wrench into what we've been doing. So one extra thing you got to be aware of. If you notice with number 9, so as we look at this together, we have 8 times A minus 7 times B plus 1 minus 2 times B plus 3 times A. So we actually have two different variables here. We have an A, so we have the variable A, and we have the variable B. Okay, so in this case, we do have two different variables, but in terms of doing the steps here, it still kind of works out the same. Now, when we get to actually combining the terms, there is something special that has to happen here with the the differences between A and B. And I'll highlight that when we look down here at the coefficients. But same kind of thing. I'm going to write my expression again. So I'm going to have 8A plus negative 7B plus 1 plus negative 2B plus 3A. Once again, all I'm doing here is I'm rewriting my expression where my subtraction becomes addition. Okay, and once again, if that happens, then my negative has to go with the term after. So negative 7b, negative 2b. Okay, so variable terms here, well, we have two different variables, so it's all the terms that have either an a or a b. Okay, so a well, it has a variable, so it's a variable term. Negative 7b has a variable. It's a variable term. 1 doesn't have a variable, so it's actually going to be a constant term. Negative 2b has a variable. It's a variable term. And lastly, 3a has a variable. It's a variable term. So actually, the only constant term that we have here is the lonely number 1 here. So 1 is a constant term. Okay. But here's where we have to differ a little bit in terms of our coefficients. Okay. We need to take note. What are the coefficients for a? Okay, so the variable a, what are the coefficients we have for a? So the coefficient for a here is 8, but we also have the coefficient of 3. Okay, so we kind of have to group it off. We need to look, well, what are the coefficients for a? Then what are the coefficients for b? Okay, well, the coefficients for b are going to be negative 7 and negative 2. All right. So we do kind of have to group together and say, well, coefficients, well, all of these are coefficients, but we need to make a note where the coefficients came from. Did they come from a variable, the variable a, or did they come from the variable b? Okay, so make that distinction, and the same thing's going to happen with number 10, but make that distinction because that's going to be something that's going to be very important as we go forward. Okay, so if you have more than one variable, make sure you're separating your coefficients into, okay, a variable, b variable. In this one, we're going to separate it into x variable and y variable, okay, because we have two different variables here. We have x's and we have y's, okay. But same kind of thing here. We have 11 times x minus 4 times y plus 2 times x plus 8. I'm going to rewrite my expression to involve only addition. So in other words, write it as a sum. And now, variable terms, once again, anything with a variable. 11x has a variable. Negative 4y has a variable. 2x has a variable. 8 does not have a variable, and that is actually the last term, the odd one out. So our only constant term this time is 8. Okay, and then once again, we get to the coefficient side of things. Well, we got two different variables, so we need to know what are the coefficients for the x's. Well, that's 11 and 2. What are the coefficients for the y's? Well, the only coefficient for the only y variable term is negative 4. Like I said, we need to separate these because, once again, in the next set of questions, we're going to be doing some things with these numbers, and we can't do anything with the 11 and 2 and with the 4. So we got to kind of separate them and say, hey, what goes with the x's? 11 and 2. What goes with the y's? Negative 4. And that's going to play a big role in the next set of questions, okay? So that's all the examples for the first part. So let's go jump right into the second part. And this is what the whole section is all about. That whole part was just identifying terms. Once again, the whole reason we want to do that is to get to this part. So what the notes say here is you can simplify an algebraic expression by combining like terms. Well, what does combining mean? That means to put together, right? And then what we're going to call like terms are terms that we can actually add together, meaning they look alike, okay? So like terms meaning they kind of look the same, okay? So in this case, this means to combine common variable terms. So notice here, common variable, that's what we were talking about just a second ago with, so x's with x's, y's with y's, okay? You can't combine two terms with different variables. So they have to have a common variable and the constant terms. So for example, that very first example that we did, we have this expression 14x plus 9 minus 2x plus 8 minus 5x plus 1. And the whole goal here is we want to make this equal to something more simple. We want to simplify it, okay? So the process we go through, and as you practice with these, you get better and faster with them. But it's the same process every single time. You need to figure out what your variable terms are. You need to figure out what your constant terms are. You need to figure out what your coefficients are. And then simply all the hardest thing here is you have to add your coefficients and you need to add your constant terms. So what does that look like? Well, once again, I'm going to rewrite this as 14x plus 9 plus negative 2x plus 8 plus negative 5x plus 1. So I can clearly see my variable terms. So variable terms here are 14x, just as before, 14x, negative 2x, negative 5x. My constant terms are 9. Oh, so I'm jumping ahead of myself here. 9, 8, and 1. And then the last part here, our coefficients are 14, negative 2, negative 5. So, same thing that we did before. But now, how do we combine the like terms? Well, in this case, we didn't have to worry about different variables in this case because everything's an x. All the variables are x's. So that means all our coefficient has to do with x's. So first step here is let's add the coefficients. So basically we just add these numbers up. So what is 14 plus negative 2 plus negative 5? And this is just simple arithmetic. Now, as I've stated before, if you need to double check yourself, especially with these negative numbers, if you need to double check yourself on a calculator, I have no problem with that. Okay, but it would be beneficial to try to do as much of this as you can in your head and then use your calculator as a check. But 14 plus negative 2 plus negative 5, okay, well, that's actually going to give us it's going to give us positive 7. Okay, so we let that sit there for just a second. So we get the number positive 7. That's what we get when we add up all our coefficients. Well, then we need to do the same thing with our constant terms. Okay, so we need to do what is 9 plus 8 plus 1. And that one might be a little easier. If you can say 9 plus 1 is 10, plus 8, it's going to give us 18. So what do we do with these two numbers that we just calculated? Well, the hard part's actually done. The hard part was figuring out what the terms are, finding the numbers, and then adding them together. Now all we have to do is, since we have this number as the sum of the coefficients, well, that's actually going to be the coefficient for our new term or our new expression. So what that means is if we add 14, and negative 2, and negative 5, we get 7. Okay? Well, since it's a coefficient, we have to put an x with it. And one way to think about it is, well, 14x plus negative 2x plus negative 5x should be 7x. But the thing to remember here is if we add coefficients together, the result is a coefficient. So once again, the number in front of the variable. So that's telling you a 7 should be in front of the variable. And then we're going to add to it what we got when we added the constant terms. So 9 plus 8 plus 1, which we just added the constant terms, which gives us 18. And actually, that is it. Okay, that's the simplified version of this more complex expression. Okay, and once again, all the trick to it is writing out your terms, understanding what are the coefficients, what are the constant terms, and then you just basically add the coefficients together and add the constant terms together, and that gives you your new simplified expression, okay? And I hope everybody here would agree with me. 7 times x plus 18 is a lot more simple than 14x plus 9 minus 2x plus 8 minus 5x plus 1, okay? So we could rewrite all of this as just 7x plus 18, okay? So with that being said, so let me do the same thing here. With all that being said, let me draw some arrows here so we can make it very clear what's going on. Okay. The 7, since once again its coefficients go with the x, the 18 is a constant term, so it's just plus 18. Okay. Now using what we just said right there, let's break it down into the steps. So in this case, let's look at number 11. So example number 11. Some of you might be able to look at this and you might see, okay, we have 4x plus 7x. Some of you might be ahead of the curve and you know that this should be 11x, okay? Once again, very simple example here. Some of you might already have seen this. Some of you might already know exactly how to calculate that. But to break it down and to tell you exactly what you're doing when you are doing that operation there is you're identifying the variable terms, 4x, 7x, okay? You're identifying constant terms. Well, there's actually no constant terms. So in this case, we have none. And then lastly, coefficients. Well, this is 4 and 7. But to remind you, what are we doing with these when we get them? Well, we're going to add them. You're always adding. And that's part of the reason, like I said, I like to do my addition here with change my subtraction to addition, because all you got to worry about if you do that is adding all of your terms together in terms of coefficients and then constant terms. So what is 4 plus 7? Well, that's actually where we get the 11. So the final answer here is actually just 11x. And remember to put the x on that because what did we just find? We found a coefficient. And then, of course, if there's no constant terms in the original expression, there should be no constant terms in the new expression. Okay. So number 12, very similar here, except for once again, we see k minus 6k. So I'm going to rewrite that as k plus negative 6k. Okay. So we do have that instance where, all right, our first term is actually just k. So if you need to, and I really do strongly suggest this because it's going to make it very clear why we want to do this here in a second, is put a 1 in front of that k. Okay, if you need to do it in the original expression, so write it there, especially if you're on pen and paper or on paper and pencil. Write the 1 in front of the k because you got to know that the number in front of this k is a 1. Because when we come down here and we want to look at variable terms, well, what are the variable terms? Well, 1k and negative 6k. There are no constant terms again, so none again. So what do? Well, we find the coefficients. What are the coefficients? We have 1 and negative 6. But we got to remember, the whole point in this is once we find the coefficients, we add them together. So 1 plus negative 6, once again, the negatives can throw people off, especially with addition, but that's going to give us negative 5. So that tells us the number in front of the variable needs to be negative 5. So negative 5k. And that's actually the final answer. And once again, that negative 5 comes from combining all of the coefficients together. Okay. And like I said, some of you might be looking at this and you say, all right, I could simply just do 1 minus 6 to get negative 5. And that's a point where I do want you to get to. But like I said, what's really happening behind the scenes is you're adding the coefficients. Okay. And once again, the coefficient technically here is 1. The coefficient here technically is negative 6. So 1 plus negative 6, negative 5, gives us negative 5k. Number 13, ratchets up the difficulty just a little bit because we actually introduce a constant term here, okay? But I'm lucky in this one because everything's already written as addition. So I don't have to write anything as addition. I don't have to rewrite this expression. But I still need to go through and say, well, what are my variable terms? Well, the variable c, so it's 6c and 11c. My constant term is just the number 1, okay? So that's the only term there without a variable. And then lastly, my coefficients are 6 and 11. But remember, we're going to be adding those. So 6 plus 11 gives us 17. Okay, so the 17 once again tells us that our new coefficient is going to be 17. So that means we got to put a c with it. And then we're going to add to it, well, since the only constant term is 1 here, we're going to add to it 1. So our final answer here is 17c plus 1. Okay. So pretty easy example here considering, but this is the first one that has a constant term. And if you do only have one constant term, then the constant term in the original expression has to be the same constant term in the new expression. Okay. Number 14, I see subtraction, so I'm going to go ahead and write that with addition. And then that opens it up to tell me, okay, my variable term here, well, there's actually only one, is negative 2y. Okay. My constant terms, I actually have 2 of them, are 7 and 12. But remember, we're going to be adding those, and 7 plus 12 gives me 19. Okay, then the last thing here is coefficient. It's going to be negative 2. So that means the coefficient here, since there's only one coefficient, it has to be the coefficient in the new expression. So what we're going to do is we're going to start off with negative 2. The variable here is y, so negative 2 is the coefficient. And then we're going to add to it our constant term of 19. Once again, that's all there is to it. You just take the coefficients, add them together, take the constant terms, add them together, and then plug them into your new expression just the same every time. The coefficient is always going to go in front of the variable, and then you're going to add to it the constant term. So number 15, same kind of thing here. Now some of you might see this from the start, 11m minus 5m, 6m minus 13. So the answer here is going to be 6m minus 13. But once again, technically what's going on behind the scenes is you have these terms. Technically you've got 11m, negative 5m, and negative 13. So what's happening here? Well, it's going to be the variable terms are 11m, negative 5m. The constant terms, well, there's only one. It's negative 13. So what we end up with here is coefficients of 11, and we're going to add to it the coefficient of negative 5. 11 plus negative 5, that's where we get the positive 6 for this one. But this one's a little tricky because you see we got a negative 13 here as a constant term. So technically the way we would write this is 6m plus negative 13. Okay? And honestly, if you gave me that as the answer, that's technically correct. Okay? But with what we're trying to do is simplify. It's not very simple to be adding a negative number, okay? So when we write it like this, usually what we do is we take it and we simplify it by writing it as 6m minus 13, okay? So basically what you can come away with here is if you've ever got plus a negative, you can actually simplify that by just writing it as minus the positive. So 6m minus 13 is the same thing as 6m plus negative 13. Okay, but honestly, if you gave me either one of these at this point, they're both the same, so I would count it correct. Okay. Number 16, you'll see a similar thing here, but once again, I would like to rewrite this. Negative 6 plus 8a plus negative 16. So variable terms, notice how quick I'm going here. Variable term, well, there's only one, 8a. Constant term, there's actually two. There's negative 6 and negative 16. Once again, we got to remember, what are we going to be doing with those constant terms? We're going to be adding them. Negative 6 plus negative 16 is negative 22. Well, coefficient here, the only one is 8. So that tells us our actual answer here is going to be 8a, technically plus negative 22, okay? But like I've said, we can actually rewrite that as 8a minus 22 because, once again, adding a negative is the same thing as subtracting the positive. So technically the most simple answer is 8a minus 22. But as I said before, if you give me 8a plus negative 22, that's exactly the same thing. I would consider that correct. Okay, so going on here. So we still have a few left, so I'm going to try to go a little bit quicker here in terms of, once again, it's kind of the same thing over and over and over again. I'm going to rewrite my expression, 9v plus 7 plus negative 3v plus, in this case, I'm going to go ahead and jump the gun here. I see this is just a 1v, so it'll become a negative 1v. And just the same, we'll go through, find all our variable terms. So in this case, we got 9v, negative 3v, negative 1v. Our constant terms, well, in this case, we only have one. Our constant term in this case is 7. Okay, so just one constant term there. And then that means we need to pay attention to our coefficients. So we're going to do 9 plus negative 3 plus negative 1. And when we add all those together, and that's the hardest, that's the only operation we really have to do here is addition. Okay, so all we're doing is adding these numbers together. 9 plus negative 3 is 6. 6 plus negative 1, the answer here is 5. So once again, it's actually an easier one because there's no negatives here. That means we're going to have 5 as our coefficient, so that means we have to include a v, 5v, and then we're going to add to it a positive 7. So that's actually our simplified version, 5v plus 7. Okay. And like I said, where these numbers are coming from are the 5 comes from adding the coefficients together. The 7 comes from adding all the constant terms, but in this case, there's only one constant term, so it stays the same. Number 18, 4 minus 2n. So I'm going to write 4 plus negative 2n plus negative 3n plus negative 19. So a lot of subtraction going on here. But like I said, it really helps you if you can write that as a sum. It really shows you what the coefficients are, what the constant terms are. So once again, it also allows us to just add everything we've got. So we don't have to worry about subtraction at this point. Because when we go to do the variable terms, we'll see that we've got negative 2n, negative 3n. Okay. Our constant terms are going to be 4 and negative 19, but we got to remember we are going to be adding those. And then I'm going to change it up just a little bit. I'm going to go ahead and look at the coefficients. Our coefficients are negative 2 and negative 3. So we're actually going to be adding those as well. Negative 2 times negative 3 gives me negative 5. 4 plus negative 19 gives me negative 15. So technically what we have here is negative 5 n, our variable's n, plus negative 15. But as always, that's not the most simple version. So like I said, if you get to this point and you're confused about going back and forth here, if you leave it like this, that's fine. But in this case, to be 100% simplified, you would write that as negative 5n minus 15. You can kind of think of it as if you ever have a constant term that's negative here, it's necessarily going to be minus whatever the positive of that number is in your most simplified expression. Okay. So numbers 20 or 19 and 20 here. So like I said, I'm going to go a little bit quicker here until we hit. There's a couple more I want to talk about special wise. So I'm going to once again rewrite this because I see subtraction here. So I'm going to rewrite that as negative 14w plus 10w plus negative 11 plus 2w. Okay, well, once again, that shows us clearly what our terms are. So we have negative 14w, 10w, and 2w are our variable terms. Our constant terms are, well, there's actually only one constant term, negative 11. And then lastly, our coefficients, negative 14, 10, and 2. Got to remember we are adding these all together. So negative 14 plus 10 is negative 4 plus 2. It's actually a negative 2. And just like before, we just take this. This is our new coefficient, so we get negative 2w. And like I said, technically plus negative 11. But like I said before, you can kind of skip a little step here if you can see this. If we're adding a negative 11, that's the same thing as subtracting a positive 11. So negative 2w minus 11. All right, number 20. So we're getting there. So we're about halfway done now with the second set of examples. Same thing here. So I see we got some subtraction here with negatives. Like I said, that looks very messy, very nasty. But if we write it all as addition, it makes it very clear, okay, what are our terms? So here we've got negative 1 plus negative 6 plus negative 5r plus 13r. Okay, so once again, we want to simplify this. So variable terms are negative 5r and 13r. Okay, constant terms are negative 1 and negative 6, but remember we are adding them, okay? And then the coefficients here should be an equal sign, which I guess it could be. It's telling you the coefficient is going to be equal to negative 5 plus 13. Negative 5 plus 13 gives us 8. Negative 6 plus negative 1 plus negative 6 is negative 7. So our answer here is going to be 8r, since that's the coefficient, plus negative 7. But just like multiple examples before this, technically this would be 8r minus 7, simplified. All right. So starting with this next one, I'm going to start streamlining this a little bit until we get to actually number 23 is actually one that I want to slow down with because it's got multiple variables there. But in this case, number 21, same kind of thing here. I'm going to rewrite it because I see I have some subtraction here. And then I'm going to kind of shortcut it here, okay? What is my coefficient going to be? Well, think of it this way. 2 steps. What's the coefficients? Well, the coefficients are 4 and negative 8. So let's add those together. So that gives us negative 4. Second part, what are our constant terms? Well, 10 and negative 1. So when we add 10 and negative 1, that gives us 9. So once again, if we break up these 2 steps, the first part tells us our coefficient, the second part tells us our constant terms. So our final simplified version is negative 4h plus 9. Once again, this is the coefficient. And where I got these numbers are from the coefficients from the original or from the updated expression, okay? And then the 10 and the negative 1 came from the constant terms here. So 10, negative 1. And once again, I'm just adding these together. So this is the constant term. And you can see how as you go through and do these, it kind of gets faster and faster because once again, you're doing the same thing over and over again. The only thing that changes here are the numbers you have to add together, okay? Number 22, same thing. I'm going to rewrite this as negative 7x plus negative 12 plus, I'm going to go ahead and call that a 1x since that's just an x, plus negative 9 plus 6x. So you see you've got more and more terms we're adding here, but same kind of thing. First step, what are my coefficients? Well, negative 7 plus 1 plus 6. What do we get when you add those together? Well, actually, this is a kind of a special one too. Negative 7 plus 1 is negative 6. Negative 6 plus 6, we actually get 0 here. Okay, so I'm going to show you here in just a second what we do when we have 0 as a coefficient. All right, but let's go ahead and take care of the constant terms. Well, two constant terms here. We have negative 12 plus negative 9. And in that case, negative 12 plus negative 9. I know dealing with negatives is kind of difficult, but I'll go ahead and tell you that's negative 21. You can double check yourself on a calculator. I have no problem with that. But just like before, that first number we calculated, that is the coefficient. So technically what we have here is we should have 0x plus negative 21. Okay? But that's not simplified. So what we need to think here is, what if x changes? Does it change this? Well, what's 0 times, let's say x was 1. What's 0 times 1? Well, that's 0. What if x was 20? What's 0 times 20? Well, it's also 0. What if x was negative 50? What's 0 times negative 50? So the thing we need to think about here is if we have 0 times x, that's always just going to be 0. So technically this is just 0 plus negative 21. And then actually with that, that's just arithmetic. 0 plus negative 21. Well, 0 plus anything keeps the number the same. So 0 plus negative 21 is just negative 21. So actually the simplified version of this expression is just actually a number. And that number is negative 21. So if you think about it, look at this nasty looking expression here. Negative 7x minus 12 plus 1x minus 9 plus 6x. Well, all of that, if we simplify it, is just negative 21. It's just a number, okay? And that does happen sometimes. And specifically, it happens when your coefficient is 0, okay? So special case here, coefficient is 0. Your answer is just going to be a constant term, in this case, negative 21. All righty, so now number 23. We get into questions that involve multiple variables here. So you see we have x's and y's, but the process is still the same. The only thing that changes is when we calculate the coefficients. So in this case, once again, as always, I'm going to rewrite this with addition. See what my terms clearly are. Okay, so first step, let's add the coefficients, but we have to be careful here. We can only add the coefficients for x together, and we can only add the coefficients for y together. Okay? So just to make this clear, I'm going to do the x's first. So in this case, what are the variables or the coefficients for the x? Well, that's negative 8. And we're going to add to it, well, what's the other one? 23. Negative 8 plus 23 gives us positive 15. Okay? So now we've got to do the exact same thing except for y's. Well, what are our coefficients for the y's? Well, negative 2. And we're going to add to it. Well, let me make that nicer looking. So we got negative 2, but we're going to add to it what? Negative 6. So in this case, negative 2 plus negative 6 is negative 8. So what makes this one different is that's actually it, okay? 1 because we don't have any constant terms. So the second part, there's no constant terms. But here, we found the coefficients. The coefficients, new coefficients for the x's are 15. So 15x. And then we're going to add to it negative 8y. But as always, we have minus a negative. So technically, the final answer here is 15x minus, so actually minus 8y. And that's actually as far as we can go because, once again, this whole section is about combining like terms, okay? Combining like terms. Well, once again, what did I say? It means the terms that look alike. Well, x's don't look the same as y's, okay? We could have x's meaning how many xylophones there are, and y's being the numbers of Yamaha dirt bikes, okay? Well, once again, we can't take xylophones and subtract from it number of dirt bikes, okay? So I know that's a really weird example there, but just to show you, the x's and the y's represent different things, okay? So you can't simply just add and subtract those terms together. So once you get to this point, that's actually as far as you can go. It would be 15x. There's no more terms with x. Minus 8y. There's no more terms with y. So that's the simplified version, okay? We'll see the same thing happen with number 24. So we have negative, I'm going to go ahead and put a 1 in here, so negative 1a plus negative 5b, okay? So we see we have two variables here as well, a and b, plus 4b plus negative 11b. So let me fix that negative there. Plus 2 plus negative 3a. Same kind of thing here. We got this big, nasty looking expression with all these different variables, a and b. But if we take our time, take it step by step. First step here, let's find the coefficient for the a's. Well, that's going to be negative 1 plus, that's a b, that's a b, that's a b. That one doesn't have a variable, so negative 1 plus negative 3, which gives us negative 4. Okay, let's do the same thing for b. What is the coefficient for b? Well, it's going to be negative 5 plus 4 plus, we actually have a third term with b, and that's negative 11b, so negative 11. When we add all those together, okay, once again, add in the negatives if you need to double check yourself on a calculator. Negative 5 plus 4 is negative 1. Negative 1 plus negative 11 is negative 12. And then this time we actually do have a constant term, but it's only the number 2, okay? Once again, these are the coefficients. First step, we calculate the coefficients. Second step, we calculate the constant term. So now we just plug it all back in. We're going to have negative 4a plus negative 12b plus 2. And just like always, we can rewrite that as negative 4a minus 12b plus 2. Same reasoning as the other examples. Addition of a negative is the same thing, subtracting the positive. Okay. Now, next two examples, very similar. But once again, we got all these different terms. Now, like I said, these are getting more and more complex as we go. So you can see, in this case, we have m and n's, two variables, two constant terms this time. You see the 14 and the 7. And then we do have the two variable situation going on here. So same as always, I'm going to rewrite this with addition so we can clearly see our terms. Okay. And then what are we going to do? Well, we've got to add the m's, the m coefficients first. So 9 plus, well, I didn't do it this time, so good thing I caught myself. There's technically a 1 in front of that m, so we have to add 1 And that's actually it. So we get 10 as the coefficient for m. Well, what's going to be the coefficient for n? Well, it's going to be -5 plus -2. So that gives us a -7. Once again, where I'm getting these numbers from, for the m's, it's the coefficient, 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 coefficient for the n's. So now the last step is, well, let's add the constant terms. So our constant terms are 14 and -7. And when we add those together, we get +7. So once again, all this big complicated expression here, we're going to simplify it down into 10m plus -7n plus 7. Once again, notice it's all addition, but we do have that unique situation where we can rewrite this as, since it's plus -7n, it's just minus +7n. And that's actually the simplified version. Okay. And just like before, we can't go any further because this is the term with m's, this is a term with n's, this is a constant term. So there's no like terms for us to add together here. Okay. 26 here. Last one of the complicated ones like this with two different variables, but same process. I'm going to rewrite this using addition. Going to include the 1 there in front of the c, just so we don't forget that. Once again, looks pretty complicated, pretty convoluted there with all these subtraction and negatives and all this. But once again, take it step by step. Okay, so notice here we've got variable of c, variable of d. So first things first, let's calculate the coefficient for the c's. That's going to be 2 plus -8 plus -1. Okay, so c, c, c. And actually that's it. So when we do that, 2 plus -8 is -6. Plus -1 is -7. We got to do the same thing for the d's. Well, in this case, it's going to be 7 plus 4. Okay, so the only two coefficients here for a d are 7 and 4, so that gives us 11. And lastly, we need to calculate the constant term. Well, actually, there's only one constant term. C, D, C, C, D here, so -5 is actually the only constant term. Like I said, all we're doing is adding these numbers together. In this case, there's only one constant term, so you can't add it together. But so that just means it's the constant term. So all this put together is going to be -7c plus 11d plus -5. And once again, we have this unique situation where we're adding a negative. We can rewrite that as -5. Okay. And like I said, if you practice with this, you get better with it. Hopefully you'll be able to just see at some point, okay, instead of going through and having to write out and calculate everything, well, let's just look. 2c minus 8c, well, that gives me -6c. Minus another 1c, that gives me -7c. Okay, well, how do I get the 11 for the d? 7d plus 4d gives me 11d. How did I get the -5 or the plus -5? Well, in this case, there's only one constant term, and we're minusing 5, so it has to also be -5 in our expression. Like I said, eventually you'll get to that point when you work enough examples, you go through enough problems, but if you have trouble seeing it that way, like I said, we're kind of slowing it down, going behind the scenes, and technically doing the operations that you do when you just look at something and simplify it, okay? So it's adding up all the terms, so adding up all the coefficients for the m's. So 9 plus 1 gives us the 10m, so 9m plus 1m is 10m. -5, okay, so -5n minus 2n is -7n, so -7n. And then lastly, 14 minus 7 is a positive 7, so you're adding 7. Okay? But like I said, if you have trouble thinking of it that way, there's no problem with you taking a little bit of extra time and calculating the coefficients, calculating the constant term, and just putting it all together. Now, the last two here, probably some anxiety going on as soon as I flip the screen here, because you notice there are fractions, okay? So to kind of go through this pretty quickly here, I am assuming, okay, at this point, people have seen fractions before. They know what fractions are. Okay, I'm just going to give you a little bit of a review in terms of how to deal with fractions when we're adding and subtracting them, okay? So starting off with number 27, this first fraction example here, okay? Notice we have the same kind of deal. We have variables of k, so our variable terms, well, those are the only two terms we have, two variable terms, but we need to add the coefficients. So technically what we've got here is we need to do 11 over 4 minus 3/8. Notice here with the fractions, I just left it as minus, okay, because subtracting two positive fractions is a lot easier than subtracting or adding a negative fraction, okay? But when we want to do 11 fourths minus 3/8, some of you might run to the calculator and say, well, what's 11 fourths as a decimal? What's 3/8 as a decimal? But I do want to say, usually when they give you a fraction like this in a problem, they expect fractions to be the answers, okay? So what that means is, okay, how do we simplify this? So let me write this bigger so that way we can clearly see what's going on. We need to do 11 fourths minus 3/8. We're combining the coefficients because they have the same variable. So 11 fourths minus 3/8, well, one of the things that we need here if we're adding or subtracting two fractions is we need what we call a common denominator. Okay, denominator being the bottom of a fraction, so we need a common one, meaning we need these denominators to be the same. Well, they're not the same. One is 4, one is 8. But we can turn the 4 into an 8 pretty easily by multiplying times 2. But if your memory serves you correct and you think about it, well, if we multiply the bottom of a fraction times 2, it's kind of like an equation in a way. If we do something to the bottom, we got to do the same thing to the top if we want the fraction to stay the same. So technically what we have here is we need to do 11 times 2, which is 22, over 4 times 2, which is 8. And now we have two fractions with the same denominator. So the trick to subtracting fractions in this case is you just subtract the numerators now. 22 minus 3 gives us 19. And then we leave the denominator alone. So 19 over 8. Once again, same step as what we've done before, just we're dealing with fractions now instead of whole numbers or integers. So once again, this tells us we've got this as a coefficient. So our final answer here is 19 over 8k. Once again, everything is exactly the same except for in this case you had to deal with fractions. You had to subtract and add, in this case, subtract fractions. Okay. Now number 28 is going to be very similar. Now this one is a little bit more involved because you've got variable terms and constant terms. So same kind of thing here. You got to be careful. So first thing I'm going to say is, well, we need to find the coefficients. Well, the v's are there. So technically we're going to have to take negative 1/6 and add to it. Which once again, I'm going to make this a little bigger. I don't want to take up too much space though. And we're going to add to it 7/15 because those are the coefficients. Okay. So to calculate this, we need common denominator. Well, talking about least common multiples, which is probably another term you haven't heard in a while, but what that means is we need to find something we can change the 6 into that's going to equal to something we can change the 15 into, okay? Meaning we need to find, okay, what can I multiply 6 by to get it to where I can get it to the same thing if I multiply 15 by something. So the easiest one to see here would be just multiply this by 15, both top and bottom by 15, top and bottom here by 6, but that's going to make it harder on down the road when we try to simplify things. So my suggestion is multiply top and bottom here by 5, multiply top and bottom here by 2. Because if you do that, what 6 times 5 is, once again, can't forget the negative here, is 30. What is 15 times 2? Well, it's also 30. So once again, the whole point here is we want denominators to be the same, and then our numerators are going to be 5 in this case. 1 times 5 is 5, and 14. Same kind of thing here. We just add the numerators, but in this case we have to remember this is a negative. So if you want to, you can take that negative and put it with the 5. So negative 5 plus 14 gives us the 9. Once again, when we add or subtract fractions, the numerator or denominator stays the same. So 9 over 30. And then to quickly just gloss over this, once again, I'm expecting people to know how to do with fractions a little bit here. We can divide both top and bottom by 3. So simplified version is going to be 3 over 10. Now we did all of that work, and all we did here was say, well, that's the new coefficient. So now we got to do the same thing, even more calculations, and figure out what the constant term is. So our constant terms here are 3/4, and we're going to subtract from it 1/2. Once again, 3/4 minus 1/2. Well, this one's a little bit easier because it's easy to see. Our common denominator should be 4, so all we got to do is multiply this one top and bottom by 2. So here we get 3/4 minus 1 times 2 is 2 over 2 times 2 is 4. 3/4 minus 2/4 is 1/4. Once again, all of this work with these fractions, okay, and what this tells us then is this is the coefficient, so it's 3 over 10v, and our constant term is 1/4. So that's actually the final simplified answer. Now do notice on the homework portion, there is only one question that deals with fractions, okay? So if you look at both of these examples, that should give you a pretty clear direction in which you need to go on that last question on the homework. But my point there being, if you do end up missing that last question, you struggle with fractions, it's not the end of the world. It's only one question out of 20, okay? So that's already a 90, it's a 95, but that's including if you get everything else right. But like I said, I don't want you to stress over it too much, but do try your best with it, okay? Need to know how to deal with fractions. So, but I guess on top of that, just let me know if you have any trouble with fractions, and maybe I can get you some resources or get you some help in figuring out how to deal with fractions, because going forward, you're going to start seeing fractions more and more and more, especially as you get into algebra and geometry. There's fractions all over the place in geometry too, okay? But with that being said, that's all the examples. Every single homework question works exactly as the examples that we covered in these notes, okay? So refer to those when you're working the examples, and good luck. And as always, thank you for watching.